All right, so in this video, we're going to go over combinations here, okay? We just went over permutations, and remember the primary thing with permutations was that order matters, okay? The big difference here with combinations is order doesn't matter, and I'll go into a little more detail here in just a second. So let's go back to the same kind of example we had before. We've got the same 4 students in class, and the teacher knows that one's going to be absent. All right, so the teacher wants to determine how many different possible groups of the 3 students there could be. Okay, when we're grouping, we're not arranging, we're grouping. The order of the students here is irrelevant, which makes it a combination, okay? When you're looking at the problems to distinguish between combinations and permutations, you want to think, is order either explicitly stated or is ordering implied, okay? If either of those things is the case, it's a permutations problem. If it's not, it's a combinations problem, all right? So for us, there is no difference between any of these 4 groups. Norma, Rohando, and Alex in any order is still a group of those 3 students, okay? So again, we're just grouping, we're not arranging. Right? So because of that, with this scenario, there are only 4 possible groups, and I'm gonna list those here for you. The first group is Norma, Rohando, and Alex. The second group is Norma, Rohando, and Taylor. Another group would be Norma, Alex, and Taylor. And then the final group would be Rohando, Alex, and Taylor. Okay, so there's only 4 combinations. All right, so if we have 4 objects, in this case 4 students, grouped 3 at a time because one is absent, we're going to use this notation just like we did with permutations. We've got the combination of 4 objects grouped 3 at a time, and that's going to be equal to 4. So there's only 4 combinations. All right, with permutations, the numbers can get really big really fast. With combinations, we're going to have some pretty big numbers, but not to the same extent usually as with permutations, okay? So because we don't want to list all the possible combinations all the time, let's say there were 20 students and 18 of them were going to be in class all the time. I don't want to list all the different possible combinations of those 18 students. So we've got a formula just like we did with the permutations, okay? So remember, N is the total number of objects, R is the number that we're placing into groups, okay? And the formula looks a lot like the permutations formula. Notice the numerator is the same, and this parenthetical part here is the same. There's one addition, though, in the denominator. We're going to divide by R factorial. And what that does is it eliminates the repetition, okay? It eliminates some of these. Remember, all of these groups were the same because order doesn't matter, so it eliminates that repetition. Okay, so looking at number 1 here, in your music streaming app, you've got 20 of your favorite songs downloaded to your workout playlist. All right, you've got a race coming up this weekend. You know, based on the time of the race, you're only going to need 4 songs to get through the race. Okay, how many different combinations of 4 songs could you make from your workout playlist? Okay, so we're not talking about an order in which the songs are played. We're just talking about 4 songs on the playlist, and maybe you hit shuffle. Okay. So N is going to be 20 and R is going to be 4. All right, so let's plug these values into my formula. So the combination of 20 objects grouped 4 at a time is going to look like this, okay? Order of operations, I've got to do the parentheses part and simplify. So that gets me to 20 factorial divided by 4 factorial times 16 factorial, okay? I'm going to show you, we're going to continue to do this manually here, and then I'll show you how to use the calculator in class to make it a little easier. So remember, we want to rewrite 20 factorial until we can cancel out the largest factorial in the denominator, okay? So I rewrote that to 16 factorial. I'm going to go ahead and expand 4 factorial here to 4 times 3 times 2. Okay, remember these are going to cancel out, okay? And then I'm going to multiply these together and divide by 4 times 3 times 2. Remember, like we did before, you can simplify. 20 over 4 is 5, 18 over 3 is 6. If you want to make the numbers a little smaller, you can do that, okay? But when you multiply all that out and then divide, you get 4,845 different combinations of 4 songs from a total group of 20, okay? All right, pause the video here, give 2 and 3 a try, and then come back and check your work. I'll go through these pretty quick. Okay, number 2. There's 14 teams competing in an Olympics event. 11 of the teams will qualify for the final round. How many different combination of teams can qualify for the final round? Again, it doesn't matter if you're the top team going into the finals or the bottom team going into the finals. You just want to be one of these 11. You just want to make it, okay? So there's no order either explicitly stated or implied, okay? So N is 14, R is 11, okay? Plug those in. Again, I'm going to do the parentheses part here. So I get 14 factorial over 11 factorial times 3 factorial, okay? Again, I want to rewrite the numerator until I get to the largest factorial in the denominator, okay? So I'm going to stop at 11 factorial there so they can cancel out, and I'm going to expand 3 factorial to 3 times 2, okay? So divide out the 11 factorials, those are gone. You could simplify like 12 over 2 here would be 6. 6 over 3 here would be 2. So you can simplify there, but go ahead and multiply everything out. And there's 364 combinations of teams that could qualify for the finals. Okay. And finally here, we've got 3 math teaching positions open at a large high school in Connecticut. 17 people have applied for the job. Okay. So how many different possible combinations of people could the school hire? Again, doesn't matter if you're the first choice or the third choice. As long as you get hired, you're teaching math at this high school, okay? So again, no order either explicitly stated or implied. So N equals 17, R equals 3. Plug those into my formula, simplify, okay? Now I'm gonna rewrite the numerator until I get 14 factorial, so those cancel out. I'm gonna expand 3 factorial, and then I'm gonna divide, multiply in the numerator, multiply in the denominator, divide those two products, and I get 680 different possible combinations of teachers for these 3 math positions, okay? So that's combinations.